Let's look at another piecewise function. And again, a piecewise function means that there's different pieces a part of that function. And this one's described f of x equals, well, it equals x plus 2 if my values of x are less than or equal to 1, or it equals 4 for all my values greater than 1. So if I were wanting to graph that, I would want to graph for all values less than 2. I know it crosses here and here and less than 1. Sorry, so that's my starting point right here. So there's a graphical representation of x plus 2 for all values less than 1. And then for all values greater than 1, I have a 4. Now there's a couple of things here I want you to pay attention, I want you to note. Now notice how these two graphs, they kind of cover their entire number line. So every x is accounted for. Also notice right here at 1, notice that the blue line, my x plus 2, x or 1 is also solution. However, on the second one, x is not a solution at 1. So that's why I have a hole on that circle on the red line and a filled in circle on the blue line representing those graphs right there. Now, one of the mistakes that I see happen sometimes when we're asked to graph a piecewise function is sometimes we might have a student that will inadvertently graph the entire x plus 2 graph and then also graph 4 all the way through. And it will have some type of an intersection of graphs. Well, this is not a piecewise function. This is a combination of two graphs superimposed on one another. So as you're looking at piecewise functions, just be careful that you are graphing what's in your domain. This red line right here to the left of -1, that's not part of the domain of that graph. And likewise, all values greater than 1 are also not part of the domain of that graph.